Thank you, Parveena. Hi, everyone. I'm Fahim, co-founder of Affine. We built a risk engine. We took more of an academic approach to restaking. A lot of us are mathematicians. My co-founder managed risk at Goldman Sachs, did funds of funds. So when we looked at restaking, we thought about, what happens if you have pooled security for multiple AVSs? If there's a multi-slashing event, how do we manage that? How do we assess that? So I'll mostly talk about our risk engine. All right. A little bit about team. As we know that there's a lot of uncertainties and risk in restaking, slashing conditions are still being developed. We already have $20 billion worth of assets, but cascading slashing could cause up to a 50% immediate loss. AVSs we're still figuring out what kind of slashing conditions AVSs will have, and they can potentially have pretty unique slashing conditions, and as a result, could be a little tricky to model. So what do we do in this situation? We decided to build the risk engine, and basically it's a Bayesian model where we have an initial prior, where we model based on multiple variables that I'll talk about in a second, and the data continuously evolves to predict the future risk of slashing risk of each AVS. Right. The models, the parameters that we look at are things like number of validators, liveliness, recent slashing events, total slashing events in the eigenlayer ecosystem or symbiotic ecosystem, total staked amount. Optionally, we also look at AVS usage and engagement, and if there's dual staking used, then what is the volatility of pricing? And right now, again, slashing conditions are still being developed. So how do we build the initial prior? We ran a lot of simulations that we'll present. I don't know how many of you have gotten a chance to look at the paper that we published on the simulations that we have run. But basically, the simulation predicts a risk score for every single AVS, on top of which we can have multi-AVSs, so an operator validating multiple AVSs, and what is the risk score for them, or even an LRT, what is the risk score for each LRT is something that we'll be able to predict. So just some assumptions of the simulation that we have run. We assumed that the risk profile would be similar to Ethereum, between 10 to 100x of Ethereum risk. So we're looking at 0.4 to 4% probability of slashing per year. Penalty is 1 ETH per 32 ETH. 0.5% APY per AVS, and 200 validators in the network. And we ran 600,000 simulations for a year. So this is the return simulation. So on the top row, you can see the APY versus the probability of the APY. It's a linear scale on the top row and a logarithmic scale on the bottom row so that it's more understandable. And on the first column, we're validating 1 AVS versus 10, and on the third column, 50 AVSs. As you can see, in the case of one AVS being validated, you get about 0.5% APY and very limited chance of slashing and getting to a negative APY. Versus 10 AVS, it gets to about 5%, and 20 AVSs, it gets to about, or 50 AVSs, it gets to about 20%. And the chance of slashing risk getting to a negative APY is really, really small. We're looking at 10 to the negative 3 to negative 4, so 1,000 to 10,000 of a chance. So there's 99+% chance that you will be at the 20% plus APY range, given that there's no cascading risk, and they're similar to 10x risk level as Ethereum. So this is a very interesting chart where, as you can see, with the number of AVSs being validated, the expected return grows linearly. The standard deviation, which is the risk, that also grows linearly. So in the third chart, you can see that the Sharpe ratio actually doesn't go up. So even if you're validating more AVSs of the same risk profile, the Sharpe ratio remains constant. So you're likely to make just more money, and it probably makes sense to validate more AVSs. But if you have a mix of higher risk AVSs, then the Sharpe ratios change. So as you can see, I'll share some EigenDA data in a second. Lagrange was here, Ethos were here. These are all blue chip AVSs, but hopefully we need a lot more AVSs to come in, some of which can be higher risk. So how do we have a mixture of this pooled security? And if you have a high risk, so we thought about 100x of Ethereum risk. And here you can see the chart between 0% mix to all the way to 100% mix of high-risk AVSs in the pool. And the return doesn't really go up as the number of high-risk AVSs are being added to the pool. In fact, the standard deviation is going up. So it's another reason to really make sure having an idea of what is the slashing risk of the AVSs that you're working with. Are they one of the blue chip ones, lower risk versus higher risk ones? So this is probably the most important slide that I want to talk about, which is the idea of correlated risk. And a lot of the AVSs can be built from the same components and can have shared slashing risk, and which can potentially be catastrophic for the whole industry. Here we look at 3 different charts. The first one is where there's 0.25 correlation between the AVSs, then 0.5, and finally 1 correlation between all the AVSs being validated. So as you can see, as the number of AVSs being validated on the first chart, expected return is not increasing linearly anymore. It's increasing sublinearly. Whereas on the second chart, which is the risk level, your risk is actually increasing exponentially. And you have an exponentially decreasing Sharpe ratio, which means if there's any correlation between the AVSs being validated, it can be very, very risky for the whole industry. Another reason to really have a sense of running the AVSs through the risk engine to see if there is any correlation amongst the slashing risk within the AVSs being validated. This is one of the dimensions that we ran on EigenDA, thanks to Lambda by P2P for sharing the data. It primarily looks at liveliness. And this is actually a beautiful chart where we can show that EigenDA is being validated by 246 operators, but the top 70 operators were live 100% of the time. So this is another reason to show that the top blue chip operators will work with the top blue chip AVSs. But what happens when you have newer AVSs coming in? What is their risk profile? And how do we enable them to also access this initial bootstrapping of cryptoeconomic security? Yeah, basically the point of the talk is quite important. We have been farming airdrops quite a bit, but soon slashing is going to be turned on, and it's quite important for our whole industry to take a risk-aware and risk-on approach. Our risk engine is open source. Anybody can use it. We're already working with many of the top operators and AVSs to publish data, and it's all going to be open source. And hopefully it will allow the restakers and the AVSs to have much more aware approach. We're still very early. There are not many AVSs that are around, and we need to go much bigger on the demand side of the cryptoeconomic security, and we've got to make sure that we don't have structural problems in the meantime, which is the primary goal of the risk engine. Some of our backers, we launched an LRT on top of the risk engine, some of our initial launch partners, and it's all accessible at affinedefi.com. You can find me at Himzers on X or email me. I'm happy to also, I don't know how much time I have. I know I'm in between lunch, so happy to let you guys go, but also I can take any questions if there's anything right now, or find me after. Any questions? I mean, as soon as slashing will get turned on, right, it's going to become a very, very key factor. Like so far, there's not really any risk. So it totally makes sense to validate all the AVSs, provided they have demand. But as soon as slashing gets turned on, you want to make sure that you're picking the right ones to optimize the Sharpe ratio. Yeah. Cool, awesome. You guys enjoy lunch, and I'll be around to answer any questions anytime. Thank you.